In this video, I want to look at some examples of the chain rule for differentiation. So most students are okay with the chain rule for differentiation in certain forms, but when the situation varies, they get a little confused or they slightly do the wrong thing. Let's start with the most basic form, which is a bracket with a power, and the inside of the bracket in this sort of linear form, which is number x plus or minus a number. When you start the chain rule, that is usually the first form that you see, and that's still usually the most common form. So there are different ways to think about how to go about this derivative, but essentially all versions of the chain rule say that you need two derivatives. You need to differentiate the overall function, whether that's a bracket or a trigonometric function or something else, and you need to multiply that by the derivative of the inside of the function. That is all that the chain rule is, two derivatives multiplied together. So if we differentiate this overall function, we can do the bracket, we can do that by using the power rule. So you bring the power in front, so it's going to be 4. The bracket never changes in the chain rule. Reduce the power by 1. So that's just normal differentiation. The thing that makes it the chain rule, we're then going to multiply by the derivative of the inside. The derivative of 3x minus 2 is just 3, like this. And then we can take an opportunity to multiply these together to make the final form 12 bracket 3x minus 2 cubed. So when most students learn the chain rule, they practice things that look like this, and they get very used to putting a number here on the end. So bracket times number. And they might do that 50 times, right, to practice it. So they get very used to that. But it's not always a number on the end, because remember, this thing on the end, this thing here, is just whatever the derivative of the inside of the bracket is. So yeah, sure, a lot of the time it is a number, but you've got to keep in mind it's a derivative. So in cases like this, where the derivative of the inside is a little bit fancier, it's not just going to be a number, it's going to have x's in it. But let's just go through the same process. So if we want to take the derivative here, going through the same steps, we bring the power in front, we leave the bracket alone, we reduce the power by 1, so that's the first derivative, and then we multiply by whatever the derivative of the inside of the bracket is. In this case, the derivative of 3x squared minus 2 is 6x. So it's not just a number, this time it's got an x in it. Still do the same thing, multiply these together, so we are going to get 24x, 3x squared minus 2 cubed. Okay, so different forms, subtly different. All that's happened here is I've made my 3x into a 3x squared, but it's changed the way you need to think about the derivative slightly. This form here, just another example. So we can go through similar steps. So f dash x here, bring the power in front, leave the bracket alone, reduce the power by 1, and then just multiply by whatever the derivative of the inside is. If it's a number, great. If it's not a number, just use it, whatever it is. So the derivative of x to the power of 4 is 4x cubed, like that. So that's the second derivative in this case. Multiply those together, so we're going to get 12x cubed, bracket x to the power of 4 plus 1 squared. So the key takeaway from this video is that, yeah, often the end thing will be a number, but often this thing on the end is also not a number. So just be aware that it's always just the derivative of the inside of the bracket that you're multiplying onto the end.